Okay. Good morning, everyone. How did the homework go? Do you have any questions? All right, so let us recall the main function we did last time, sine inverse of x or arc sine of x. What does it represent? Who would like to answer the question? And please put your camera on. Okay, what does it represent? Shall I pick, or you guys want to volunteer? Alex Baginski, would you like to give it a shot?
I'm sorry, what did you say?
Finish my sentence. Sine inverse of x or arc sine x. What does it represent?
It represents the inverse function of sine.
Yeah, what does it mean? What does it mean to you? Crucial.
I don't really know how to put it into words, to be honest.
Okay. All right, that's fine. That's fine. So it represents the angle. It represents the angle between minus pi over 2 and pi over 2 is the angle whose sine is x. That's the important idea. So arc sine or sine inverse is the angle whose sine is x. Okay. So if I say sine inverse of x or arc sine, they mean they are synonymous. They mean the same thing. Equal to theta. What does this mean? What does this mean? What does mean sine inverse of x equal to theta? So sine inverse is the angle whose sine is x. So saying sine inverse of x equal theta means that the sine of theta is equal to x. Okay, so that's really, and also tells me that the angle theta lies between minus pi over 2 and pi over 2. Okay, so that's really important. So sine inverse of x is theta. It means the sine of the angle is x. So what is the sine inverse? You have the sine function. You give it a number, you give it an angle. The sine gives you the sine of this angle. So, sorry, you give it an angle theta. The sine gives you the sine of theta. The sine inverse of it goes backward. You give it the sine, it gives you the angle. So that's really what the sine inverse is. All right. So I see one questions on chat I will do, but before that, I want to go through number 1 in the assigned homework to make sure you understand the writing carefully. So please have your calculator ready, and I want the following question. Number 1 tells you, find the following. Sine x if x equal half a degree. Then they ask you, find sine inverse of x if x equal a half. And then they ask you to find sine x to the power minus 1 if x equal a half. And the goal of this problem is to help you basically differentiate between those two notations. That's really the goal of this problem. All right, so who would like to give me the answer to the first one? Okay, I want it on chat. What are they asking me here? Sine x if x equal 1/2. What are they really asking us for? Okay. Caleb? Can you give me the answer? Caleb, are you with me? Caleb, I know I have two Caleb in the class. Caleb Stage, are you with me?
Yeah, I am.
Okay, please answer the first question. You have a calculator, right?
Yeah, one sec.
Okay, please quickly. We have a lot to talk about. You have to work quickly or we'll never finish. Then I will go very fast and you will be totally lost. It takes so long. Anybody found the answer? Till Caleb got his. Remember, no, it's not 30. Be very careful. The first question, they want the sine of the angle. They don't want the sine inverse. So now it's sine of a half a degree. It means you plug in a half for the sine. This is going to give you what you guys are giving me. That's the correct answer. So in this problem, they're asking you the sine of a half a degree. Half a degree is very, very small. So why you're getting a small number? Because if you think a little bit about it, half a degree is, remember, the sine is the y coordinate. Half is very, very, very tiny. So the sine of it, which is the y coordinate, is also very small. That's why we're getting a very, very small number. Question number 2. What are they asking you about? What sine? So they want you to plug in 1/2 here. But what's sine inverse of 1/2 now? What are they asking you? Now it's your 30 degrees. Now it's the arc sine. Now it's, you guys are fine. That's the arc sine. That's the angle whose sine is 1/2. Okay, now what's the last one? Now the last one. Be very careful. Where it's a very bad notation, but that's the notation that we have to use. So sine inverse is the angle. What about sine x? Rebecca's giving me 114, everybody, because what's this? It means, so that's important. This is 1 over the sine of x. So do not confuse this notation with that notation. That's the sine, 1 over the sine of x. It means 1 over the sine of a half degree. So what goes inside now is the angle because it's the sine. So it means 1 over 0.0087. And now it's 114. This one I think now you're right. So it's 1 over what we got before, which is 114.59. Okay, so what's the goal of this problem? The goal is to differentiate between those 3 things. Sine of an angle, which is the y coordinate. You just plug in, is 0.0087. That's the sine inverse. This gives you the angle. So now I'm looking for an angle. And which angle? Is the angle where you find its sine, you get a half. That's the 30 degrees. Sine x to the -1, it's 1 over the sine of x. Very different. It has nothing to do with the sine inverse. It means 1 over that. Okay, so very crucial problem. So that's the sine inverse. Now the same token, we have the tangent inverse. So I want you to finish the following sentence. Tangent inverse of x equal theta. What does this mean? I want you to write this sentence in terms of theta. What does this mean? It's the same thing. Sine x to the inverse is the same thing as cosecant x. That's a good question. It's verbatim the same thing. Okay? All right. Tangent inverse of x equals theta. What does this mean in terms of tangent? I would like to answer the question. What does this mean in terms of what am I telling you? If I tell you the tangent inverse of theta, what am I telling you? It's equivalent to say what? That's what I'm asking you. It means the tangent of theta is equal to x. So tangent inverse is the angle whose tangent is x. And theta, these are the restriction on theta between minus pi over 2 and pi over 2. So that's the tangent inverse. And the same thing, cosine inverse of x equal theta. It means the cosine of theta is equal to x. So these are the main definition. That's the inverse. So in the cosine inverse, I know the cosine is giving me the angle. And this goes between 0 and pi. Okay. All right. So now we go through your question and then I proceed. So I'll go through number 6. That's the questions that you guys asked. And I will do 2 more. Number 6 is the following. Solve the equation for a value of theta in the first quadrant. So they only want one solution, the one in the first quadrant. And the equation is 10 tangent theta minus 5 equal 15. And they want a solution in the first quadrant. It means between 0 and pi over 2. And they want the answers in radian and degrees. Okay, so to solve this, basically I need the angle. First, I'm going to isolate the tangent, because if I know the tangent, I know the angle. So isolate the tangent. Isolate tangent theta. So to be able to do that, first, what should I do? Quickly, what should I do?
Add 5 to both sides of the equation.
Okay. I add 5 to both sides. Then what should I do? It's 10 multiplied by tangent. How can I get rid of 10?
Divide by 10.
Divide by 10. So I will have tangent theta equal to 2. Once I isolate the tangent, now the question is to find the angle. I know the tangent, I know the angle. That's what the tangent inverse is created for. That's exactly what's created for. So this would give me, and I want one angle. Theta is tangent inverse of 2, or I keep writing it both ways because I want you to know both, or arc tangent of 2. So it's tangent inverse. So that's what this new function, this new thing we call arctangent, that's what it is for. It helped me to solve this equation. Now they want it in degrees and in radian. So we take our calculator, and my calculator right now is in degree mode. So I'm going to stay in degree mode and give the answer in degree mode. And then I switch to radian. So I need tangent inverse. So you just put in the tangent inverse of 2. I'm getting 63.43 degrees. So in degrees, theta is 63.43 degrees. In radian, you can either convert degree in radian manually, or you can, if you want, you can go back and just to practice your calculator a little bit, you can go to mode, put your calculator in a radian mode, and then go back and find tangent inverse of 2. And this is 1.107. So or theta is 1.01. Sorry. Theta is 1.107. And that's in radian. When there is no unit next to the angle, it means radian. When there is the degree, so you'll have unit. In this case, if there is no unit, it's always imply the unit is a radian. That's the way you guys will encounter that. Okay, and that's really so now if I know the tangent, I know the angle. That's really the benefit of those. Any other question beside number 6? Okay. would like to do, and actually I will give you the chance, I put some problems on Bright Space, and suppose I tell you solve the following, because I think those are important problems. Everything we're doing is crucial for you. Suppose I tell you solve the following. Sine t, that's what I gave you, 0.7, if my memory is right, for t between, let us say, and 2 pi. Okay, I give you 3 minutes to do it, not more than that. Actually, 3 is a lot. And if I put 2 pi, I mean I want angle in radian. If I put 360, I want the angle in degrees. So it depends what I'm asking you for. So please solve this quickly. And answers on chat. Please, those without a camera, put your camera on. Okay, so I'm having answers. You're giving them to me. Okay, so sine t equals 0.7. One value is the sine inverse. That's really, what is it for? That's how powerful this function is. And now if I am in radian, this is gonna give me 0.77. That's what you guys are getting. You guys are correct. But let's give me one of them. I want all of them. And the other one is I'm gonna pick it up from the unit circle. 2.36, you guys are right. So sine is 0.7, that's 0.7. And the sine is the y coordinate. So the calculator gave you that, 0.77 radian. It's like almost 50 degrees, and we have to pick up the other one. We have to pick up the other one. So the other one would be 2.37. So the way they picked it up, they took pi minus 0.77. And I trust them to 0.366. They rounded up to 0.367. Okay, right? One more, and then I proceed. Suppose I tell you solve, I don't know, sine t equal minus 0.8. And this time I give you the between 0 and 360 degrees. So this time I want my angle in 360. Make sure your calculator is in degrees. Okay, so you have to know what unit should be. Again, I give you 3 minutes, and I want answers on chat. And I have to do it myself. Okay. Be careful with your answers. Be careful with your answer. There is a minus in here. Be very careful with your answers. Okay. I'm not getting correct answers yet. Be very careful. I want my answers. Yeah, this is correct. I want my answer between 0 and 360. I want you to fix what you have. I'm not getting all correct. You're getting it half correct. I want all of it correct. Okay. All right. Let's see what's up. Let me start with what you guys gave me. So everybody, we did the right sine inverse of minus 0.8. Okay, and everybody gave me the following answer. Minus 53.30. Okay, so far so good. Okay, now, if I want the angle between 0 and 360, if you don't draw your unit circle, you're going to be confused in those problems. All right, if the sine is minus 0.8, that's minus 0.8. The sine is always the y coordinate. Where is the minus 53 on your picture? That's right there. This is what your calculator is giving you. Okay, that's what your calculator is giving you. Now, if I want the angle between 0, that's a positive number, and 360, and I want all of them. So we know that this one is also have sine minus 0.8. What is this angle? So now we're going to give the answers. What's this angle? The one in blue that you guys see. If this is 53, this is right here 53. So this angle is going to be 180 plus 53.13. And that's, you guys picked this one, which is 200. No, sorry. So it's 180 plus 53. And that's 233. That's, some of you picked it up. It's positive because I want the positive angle. So this one is 233.13. Now, the minus 53 is acceptable. But if I want only the angle between 0 and 360, because sometimes we only want those, it means I want this one, the positive one. And what's the positive one? Look at the picture. The positive one is actually 360 minus 53.30, which is, I think some of you picked it up already, which is the 306.87. Okay, so this is correct. If I did put any restriction on you, you give me that. But because I want them between 0 and 360 and I want all of them, you go back to your unit circle and figure them out. How did I get minus 53? I got it like this. You go back to your calculator. Okay, you get it to your calculator and you compute the sine inverse. So the sine inverse. Are you with me? The student was asking the question. Sine inverse of minus 0.8. That's what the minus 53 does. That's what, you know, the sine inverse does. It gives you the angle whose sine minus 0.8. It means this is the sine. That's the minus 0.8. My question is, the calculator give me this angle, which is the minus 53. That's the one, your calculator. Is that clear? Any other questions? All right. So it's a crucial idea, not hard, but it's very important, the notion of the arc sine. It's the angle. So we know the sine, we want the angle. All right, today we're going to move to chapter 8, and it's a relatively easy section because most of you have been exposed to it, but we have to go through that. So 8.1, trigonometric function. Trigonometric function in a right triangle. Okay, first let us remember what right triangle is. Right triangle is a triangle with a 90-degree angle. So right triangle is a triangle with a 90 degrees angle or a pi over 2 angle. Okay, so that's a right triangle. So this is typical right triangle. This is my right 90-degree angle. And in a right triangle, this side here, the one opposite to the 90 degrees, is called hypotenuse, as you guys remember. And those two sides, sometimes we call them the legs of the triangle. Legs of the triangle. And the notion of hypotenuse only exists in a right triangle. Otherwise, there is no such a thing as a hypotenuse. Now, whenever we have a right triangle, we have the famous Pythagorean theorem, which is we have to remember it because it's important. So let us recall Pythagorean theorem. Which was a revelation when it was discovered. Okay. So let us recall that. The Pythagorean theorem tells me the following. If I have a right triangle, and that's crucial, it has to be right because it doesn't work if my triangle is like this, which is we're going to talk about it next time. Nothing that I'm writing today makes sense. So only in the right triangle, and let us remember what's the relationship between the side. Okay, can you guys remind me quickly? Because I know all of you know it. What's the relationship between the side? What does it tell me? A square, this side square, plus the other leg square, give me the hypotenuse square. A very basic relationship, absolutely crucial. Now, for example, let's find the missing side. So a very simple problem. I'm asking you to find the missing side. Okay, so what do I mean by that? So I'm going to draw a triangle. I'm going to do two simple ones. And I'm going to give like numbers. Suppose I call this is 1 and this is 2. Find the missing side. It means find the C. Okay, we are in a right triangle, and I repeat, it has to be right for Pythagorean to work. So Pythagorean tells me that C square is 2 square plus 1 square. It means C square is 4 plus 1, which is 5. C equal the square root of 5. That's my side. So this is square root of 5. So that's one of the benefits of the Pythagorean. If I know two sides, I know the missing side. But it has to be right. Otherwise, it's wrong. And next time we'll see what to do with that. Suppose I give you the following now. 2 and 3. Question is, find B. Okay, I give you a minute to give me B, quickly. You find it. How much do you guys get? want the answer on chat, it should be quick. That shouldn't take us much time. Okay, we're getting there. So Pythagorean tells me if I take 2 square plus b square is the hypotenuse square. So first you write it this. And the goal is to find b square. So we need to isolate it. 4 plus b square equal 9. B square is 9 minus 4, which is 5. B is the square root of 5. Why did I get square root of 5 in both problems? It's just a pure coincidence. There is no reason or whatsoever. Okay. So this is what Pythagorean theorem in a right triangle. It's fairly useful. Now I'm going to move back to the trigonometric function in a right triangle. And this is only true in a right triangle. So the trigonometric function. And this is what you guys probably trigonometric functions. When we say trigonometric functions, I mean the sine, the cosine, the tangent, and so forth. Now, suppose we are in a right triangle. So I'm going to draw it. So this is my right triangle. Okay, this is my angle theta. Okay, and let us remember a little bit. If this is my angle theta, that's my right triangle. Angle. This is always the hypotenuse. If this is an angle theta, this side is called the opposite side to theta. And this one here is called the adjacent side. And I'm sure you guys have seen this. I'm not pretending you guys haven't seen that. Okay, so that's the hypotenuse. That's the angle theta, the opposite, and the adjacent. Now, we're going to define the sine of theta. And this is a trigonometric function in, and the word right is important. Right triangle. Triangle. Okay. So let us recall all the trig function. The sine of theta, if I am in a right triangle, the sine of theta is defined to be the opposite side divided by the hypotenuse. Okay. Now, before I move on, when we defined the sine in the unit circle, and as I told you before, I tell you now, that's the unit circle will be the definition you will use and as an engineer a lot of time. But this, if I took an angle T here, or theta, I don't care what we call it. We took the unit circle here. This side was 1. And we defined the sine to be the y coordinate. Our definition here and our definition here is exactly the same. We're not really changing the definition. Because if you take this angle theta, the y is the opposite. The hypotenuse is 1. And we defined it to be the y coordinate because we took a hypotenuse as 1. So this definition is not different from that as long as I am in the first quadrant where my angle is less than 90 degrees. What our unit circle definition did extended the meaning for angle more than 90 degrees because this idea stopped. The minute I have my angle bigger than 90 degrees, I don't have hypotenuse. I don't have, this whole concept falls apart for bigger than 90. And that's where we have to go back and use the unit circle. Okay, so this definition is restricted for right triangle. It coincides with our definition, but this does not extend for angle larger than 90 degrees. There is no more idea of hypotenuse at all in that definition. Now the cosine. The cosine is defined, here is the x coordinate. It means the adjacent over the hypotenuse. Okay. Now the tangent. The tangent is always sine over cosine. It's always sine over cosine. So it's sine over cosine. Now, if I am in the right triangle, so let's see what's the sine. The sine is the opposite over the hypotenuse divided by adjacent over the hypotenuse. So now if I use the properties of fraction, so that's opposite over hypotenuse times hypotenuse over adjacent. So I know it's a little bit of math, but I'm trying to convince you that we're doing the same. It's sine over cosine. Those cancel each other out, and I will be left with opposite over adjacent. So in the right triangle, the sine opposite over hypotenuse, adjacent over hypotenuse, the tangent is always sine over cosine, but in a right triangle, it becomes also the opposite over adjacent. Like in a unit circle, it was the y over the x. Okay? And then the others are the same. You know, secant, I will not change, is 1 over cosine. Cosecant is 1 over sine. Cotangent is 1 over tangent. Or if you flip those, it becomes adjacent over opposite. Okay, so those are all the trig functions that you should memorize in the context of the unit circle, okay, and in the context of a right triangle. All right, so let us practice those a little bit because it's not hard section, as I said. Can I move on? Okay. So let us do 3 problems to solidify this definition. So my question is, find the following. For each of the triangle, I want you to find sine theta, cosine theta, and let me pick tangent theta. Those are the most basic one, and let's pick secant, for example. Okay, so I'm going to give you a triangle, and you have to find each one of them. So this is my triangle. This is my theta. And this is 6. And this is 5. Okay, and my question is, find sine, cosine, tangent. I give you 1 minute to find the sine. Use your definition and everything we did so far. Okay, please put your answers on chat. Anybody? Okay, I'm having something. All right, anybody else? Anybody else? Just to make sure that he's right. I don't do those problems. I see what you guys did. Is your classmate right? Yes or no? Okay, 0.768. We have to see how you got that. 6 over, all right, so let's see. The sine is opposite over hypotenuse. The opposite is clear. The opposite here is 6, so I don't have a problem with the opposite. The hypotenuse, I don't have it. I have to compute. So I'm going to call this C, because that's the hypotenuse, and then I'm going to compute the hypotenuse. I have Pythagorean tells me this is 5 squared plus 6 squared. It means the 6c squared is 25 plus 36, and that's 1. That's give me 61. So my C is the square root of 61. So I cannot move any further except this is the square root of 61. So now this is divided by the square root of 61. And I will do the math to make sure you guys are giving me divided by the square root of 61. I'm getting almost, and that's an approximation, 0.768. Okay. All right. The cosine now become fairly simple. The cosine, now I have everything. It's the adjacent over the hypotenuse. And that's what give me the 5. That's the adjacent to theta. And divided by the square root of 61. Tangent, so is the opposite over the adjacent. And that's 6 divided by 5. And finally, I ask you for the secant. I can ask, it's 1 over the cosine. It means 1 over, all right? What's the cosine? The cosine is 5 over the square root of 61. Now, if I use fraction, you multiply by the reciprocal. Means square root of 61 divided by 5. Okay. All right. Example number 2. So as I said, we're going to do just a bunch of examples to practice those. Example number 2. The question is, find theta in each of the following scenario. So this time, I want you to find the angle in each of the following scenario. So this time I want the angle. All right, so I will draw my graph. Sorry. So I'm going to take, this is my right triangle. And I'm going to put 8 here. I'm going to put 5 here. And this is my angle theta. How I'm going to find the angle. I'm going to use the trig function. We're going to use what we've learned in the previous section to be able to find the angle. All right, Jacob is telling me something. Okay. All right, your classmate is suggesting, look at tangent theta. The picture is giving me tangent theta. So according to the picture, the tangent is the 5 over 8. And now, here is the importance of the exactly. Now that I know the tangent, I know the angle. And that's what the arc tangent gives us. That's why it is so important. Now it's the arc tangent of 5 over 8. So that's really the importance of those arcs. They're extremely important because I know the tangent, I need the angle. And now this is equal to what? In this problem, I want answers in degrees because they make sense to us in a way. So what is it now? I don't know which mode my calculator is in now. It's in degree mode, so I am safe. So I want tangent inverse of 5/8. So I'm getting 32 degrees. Yeah. Point whatever. So we can, it's almost 32 degrees. Okay. So this one here, this is 32 degrees. Okay, so if I ask you about this angle, is this an easy or a hard question now? Easy. How much is this angle? Very quickly. How much is this angle? 58. This is 90 degrees minus 32, which is going to give me 58 degrees. Okay, so once I know now, because the sum of the angle in a triangle is 180 degrees, so this is going to give me that. All right, so example number 2 along the same line. Okay, so suppose I give you, I thought that's the easiest section in this whole course. Theta, okay? Find theta. Please, I want all of you to do this problem. You look at the picture and you ask yourself, which is easiest to find? Okay, do you guys agree with your classmate? That's the arc sine, exactly. So here I use the sine because I have the opposite. And let's give me the theta is the arc sine of 5/6. And I use degree here just to give you, make sense, to help you make sense out of this, at 56.4 degrees, okay? Because otherwise radian will not be very clear for you. So this will give you 56, which is almost a radian. Because 1 radian, to help you in your mind think about radian, a radian is almost 57 degrees. Keep this number, try to memorize this. It's really helpful for you because it gives you a picture. What's really a radian in your head? So 56 is almost 1 radian. So try to memorize this conversion because it helps you make sense out of radian. Otherwise, radian will be a bizarre concept in your mind. Right. So the last problem we're going to do along those lines is the following. Suppose I tell you, find the missing side. Okay, so find the missing side. So I'm going to give you something and you guys have to find the missing side. So I'm going to give you that. I'm going to tell you this is the smaller angle. So I'm going to call this 35 degrees. I'm going to call this 2. Call this is R. And that's it. And I'm going to call this A. Find the missing side. It means I want you to find A and R. Get going. Please, each one of you should be able to do that. Each one of you have to think about it to be able to give me the answers. Those are not hard questions. And there are several ways of doing this problem. Let's see what you guys come up with. So somebody tells me something for A. So one of your classmates is, we're trying to find A. So your classmate decided to find A first. So what did they do? What did the student do? If you want to find A, you have the angle, you have 2, and you have A. So you don't want to deal with the hypotenuse. The only function that avoids the hypotenuse is the tangent. So the student said, okay, I take the tangent of 35, which I know what it is equal to a divided by 2. And then she solved for a. To solve for a, I know what tangent 35 is. You multiply by 2 across. So multiply by 2, so she can solve for a. And this would give her a equal 2 times the tangent of 35. And then we solve for the a. And this is where we need a calculator for. Tangent, so 2 tangent 35, which give me 1.4 almost. Okay. Now find r. Okay, so that's the picture. I want r. Okay, Jaden, give me 5.96, but you have to tell me how you found it, because you can do it in several different ways, not only one way. So Jaden, you gave me the answer. You tell me how you do it. Just write something. If you cannot, just tell me, how did you get 5.9? I found it. Okay, so to find r, one way to do it, I have 2. And I have a to be 1.4. To find r, we can use the Pythagorean theorem right there. Okay, so there are several ways. One way is to use Pythagorean theorem. So, okay, to find r, use Pythagorean theorem. Tells me that if you take 2 square plus 1.5 square equal r square. Okay, so these are the legs. The sum of the legs square give you the hypotenuse square, and that's exactly what we did. And then he just plugged in number in the calculator, and he got 4 plus 1.5 square, which gave us 6.25 equal to r square. So the r is this. Why 1.57? I don't know. What did I do? Oh, thanks a lot, Jaden. I have no idea where I got that from. So it's 4 plus 1.4 square. So it's going to give me 5.96. And then r is easy. It's the square root of that. So we just compute the square root of this and we get our answer. 2.44. Okay. All right. I know when it's the time for the quiz. I happen to be putting the quiz on. All right. So that's going to give me 2.441. All right. So that's the idea of this section, which, what I said, is a relatively easy section, but make sure you do the problem. How are we going to move forward? Move forward in the following way. This time we only took right triangle, and everything I say only work in the right triangle. So the question is, what if I don't have a right triangle? Any triangle. Any triangle. And let us say I know 2 sides. How can I find the last side? So what we're going to do next time is basically to move from a right triangle scenario to a non-right triangle scenario and see what will be the situation. And because a lot of time you guys will be working with this triangle, not everything we work with is right. So how to handle this case? Everything I did so far will fall apart. It doesn't work because Pythagorean is very limited to right triangle. Extremely useful, limited. But the question is what to do in a scenario like that. If I have this scenario, how can I find this angle? So whatever we did now, we're going to do it next time with a totally different formula and proceed. Okay. All right. So that's it for today. The quiz is up right now. Please get going.